Hi, pre-calculus. I'm going to talk about 611 and 612 today. So that is the law of sines and law of cosines. So basically, it's a way to solve triangles that aren't right triangles. Back in, I think it was maybe chapter 2, we did some review where it showed up in the homework where you had to remember all of the right triangle trig ratios from geometry. So if you have a right triangle and here's our angle theta, the tangent of that angle is the leg opposite over the leg adjacent. So when we look at this triangle, the H is the hypotenuse. Okay, so opposite this, that means across from it, this is the opposite, the leg opposite. And then this is the leg adjacent. So then sine of an angle is opposite over hypotenuse. Cosine of an angle is the leg adjacent over the hypotenuse. Okay, so we had these from before. But the trouble is, not all triangles are right triangles. So if we look at these couple of examples here, if I wanted to solve these triangles, what I would have to do is I would have to break it into right triangles and say, okay, I know this angle and I know this side. So then I could find like this little piece here and I could find this angle. So I could play around with it and I could figure out all of that information based on what's going on with right triangles. What we did in class is we derived something called the law of sines. So the law of sines works when you know two angles in the included side or two angles in the not included side. So you might remember back from geometry, you had these triangle congruence rules like angle, angle, side, side, angle, side. And those always gave you congruent triangles. So law of sines works when you have two angles and then one of the sides. And what we figured out was this ratio. So if I know the sine of the angle and the side across, right? If I know 3 out of 4 of those things, I can solve for the fourth. You might be looking at this saying, wait, but there are 6 things, right? 6 angles and 6 sides. Really, you just need any 2 out of 3, right? So if I know like these, right, or I know these 2, I can set up a ratio and I can solve it. Notice that the angle is across from the corresponding side. So when I say angle A, side A is the side across. Angle B, side B is lowercase, the side across. So we use capital letters to represent the angles. The opposite sides, we're going to use lowercase letters. Okay, then we also talked about, well, how do I solve a triangle that can't be solved with the law of sines? So if I look at this one, I have angle, side, angle. I can use law of sines. This one I have angle, angle, side. I can use the law of sines. But when I look at this one, I have a side, an angle, and a side. So in order for the law of sines to work, I have to have an angle and the corresponding side across. I need to have one of those ratios where I know both things. And then in the other ratio, I can have one thing missing. In this case, I have an angle and a side across that I don't know. So that is when we're going to need the law of cosines. And again, we derived this during class. Law of cosines we're going to use when we either have side, 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 or side, angle, side. And notice in this formula that it has the c squared and then a squared plus b squared minus 2ab times the cosine of c. It's not always, we're going to have triangles labeled ABC all the time. In this relationship, it's always that whatever this angle is, whether it's A, B, C, D, Q, R, S, whatever, this angle, and then this is the side across is always over here. And then these are just the other two, the order doesn't really matter. So there might be things that are labeled A, B, and C, but the angle we know or are trying to find isn't actually the letter C. So this right here is just the angle we know or want to find, whatever letter it is. This is the side across from it, right? And then these are the other two sides. Okay, and then the other thing that we came up with during class was an alternate formula for the area of a triangle. So we're used to the area of a triangle being half base times height. That works really well if you have a right triangle. If you don't, it's kind of like it's 2 right triangles that we have to add together. So what we figured out was there were kind of 3 different cases depending on what angle you knew. Usually when you see this formula, you'll just see it written like this. And if you look at this triangle, angle C is here and then here are sides A and B. If I look at this rule, I have angle A is here, and then here are sides B and C. Notice that the relationship is always, the angle that is included between the two given sides. So like in this one here, I know angle B and then sides A and C. So instead of memorizing 3 different forms, it's really, if you're given 2 sides and the included angle of any triangle, the area of the triangle is half the product of the lengths of the 2 sides times the sine of that included angle. So usually this is what you would see, like this is what we would put on your, the resource page is this one right here. It's really the relationship that's important. It's half the product of the 2 sides times the sine of that included angle. So we're going to practice using and applying these formulas right now. It's really important that your calculators are in degrees. So if you have your own Inspire, make sure it's in degrees. You need to go to settings. And then I think it's number 2 is document settings. You need to be sure that it's set in degrees. It could be in radians for some of the things that we did with trig earlier in the year. If you have a scientific calculator, make sure it's in degrees. If you're in Desmos, it defaults to degrees. And I'll show you, we're going to use Desmos today to do some calculations. So I'll show you where that toggle is for degrees and radians on Desmos. All right, so let's get into this. So a lot of times you're going to be asked to solve the triangle. When you're asked to solve the triangle, you're trying to find all the missing sides and angles. So in this one right here, we can start out by finding this missing angle. We know the sum of the angles in a triangle is 180, so I can just subtract the 74 and the 39 from 180 and get that this angle here is 67. Okay, so let me reset a little bit. Okay, so this angle here is 67. Now, everybody wants to know, well, how do I know if I use law of sines and cosines? And you can kind of just memorize, oh, this is angle, side angle, that's law of sines. What I generally do is I just look and see, all right, law of sines is going to be faster to use. So I always look for that one first. And what I need to use law of sines is I need a pair where I know the angle and the opposite side, I know both values. And if I know both values, then I can use the law of sines. So I can see right here, I know this angle and I know the side across from it. So I can set up a ratio that the sine of 67 degrees over 17 equals, and now I want to find one of these 2 missing sides. So I'm going to just pick one to start with. It makes no difference. I'm just going to pick the 39. Why not? Right. And I'm going to call the side across from this x. So I'm going to look for x. So I have the sine of 39 over x. And so I'm going to solve this equation. It's a proportion, right? A fraction equal to a fraction. So what I can use is that idea of multiplying on the diagonals and setting them equal to each other. Because and the reason that works is because if, hey, I don't want this x here, I'm going to multiply both sides by x, and then I don't want this 17 here, so I'm going to multiply this by 17 and this by 17, kind of like multiplying through by your common denominator. When you do that, what you end up with is x times the sine of 67 equals 17 times the sine of 39, which is the same as if I multiplied this diagonal together, right? X times the sine of 67 equals 17 times the sine of 39. Okay, so instead of like thinking of this every time, when it's a ratio or a proportion, you can always do that. You might remember that way back from, I think it's even middle school, right? If you have A over B equals C over D, you can solve AD equals BC. That's what I'm doing right now. All right, so now I'm not going to put these into my calculator and get decimals. I'm going to put it all into my calculator in one shot. I want the x by itself, so I'm going to divide by the sine of 67 degrees. So then x equals, this is gone, right? It equals whatever this is. Okay, so in decimals, if you remember, sine of 39, 17 sine of 39 over sine of 67. Let's see if I can remember this. Okay, so in decimals, see right here, it says degree. If I click that, it'll turn to radians. Okay, so fraction bar, what did I say? 17, and then sine, I don't want to screw this up, sine of 39. All right, sine of 39 over the sine of 67, and it tells me 11.62. All right, I'm going to round to the nearest hundredth. Now, if you were to put into your calculator the sine of 39, get a decimal, then multiply it by 17 and then round and get a decimal, and then put the sine of 67 in your calculator and get a decimal, and then divide. You've rounded like 4 times by the end. So you really want to just kind of put the whole thing into your calculator at once so that you have the most accurate answer possible. So x is 11.62. So this is 11.62. All right, then I want to get this side over here. So I'm going to set up another ratio. Now, some people will think, oh, I know 2 sides of the triangle. I can just use Pythagorean theorem to get the third side. That only works in a right triangle. You cannot just say 11.62 squared plus 17 squared equals y squared. It doesn't work that way. You have to set up another law of sines ratio. Okay, so when I do it, I usually, if I have a pair, I just stick with that pair, right? I'm just going to use that again. And then I'll have the sine of 74 over y, and then I'll solve to get my y. All right, so the sine of 67 over 17, I'm going to use that one again. And then the sine of, what was it, 74 over, I called that one y. Just making sure I'm writing this down correctly. All right, so I want to solve this, and it's always going to, and some of you are going to get to the point where you can kind of just look at this and do the solving in your head, because you're going to have this times this equals this times this. Or not in your head so much as if you have this written down, you could just enter it into your calculator, like this part, the solving part, without even having to write this down. So if you get to that point, I'm fine with that. Just, I really do want to see that you have this set up. Right, so you might get to the point where, oh, I know I'm going to have to multiply this by this and divide by that, just looking at that proportion, and you know this is what needs to go into your calculator. So 17 times the sine of 74 divided by 67. So the nice thing about decimals is, I can just go into here, I can click into my previous step and say, oh, it's the same ratio, except for now this is 74. So 17.75. All right, so 17.75 is my y value. And then I have solved, I'm just making sure I'm writing this down correctly. I don't have any mistakes in my work here. All right, so 17.75, now I've solved this triangle. Now the other thing we can do is we could figure out the area of this triangle using that idea of half, do it up here, I think. Half AB sine of C. Now remember, no matter how this were labeled, the angle, this is the angle, and these are the 2 sides that make up the angle. I know all the angles and all the sides at this point, so I could do this based off of any angle, just using the included sides. All right, so I don't know, I think I'm going to use the 74. The sides that make up the 74 are the 11.62 and the 17, and then times the sine of the 74. Again, just that whole thing, put it into your calculator. All right, so I would have 0.5. Oops, I don't think I hit the point there. 0.5 times, what did I say, 11.62 times 17 times the sine of 74. So 94.94 square units. So 94.94 units squared. Okay, so that would be the area for this triangle. All right, so this one works the exact same way. So I would first start by figuring out this missing angle. So I would do 180, take away the 43 and the 80 and get 57. So this is 57. And then I look at that and say, all right, do I have a pair where I know the angle and the side across? If I do, I'm going law of sines. If I don't, I'm going to do law of cosines. Again, I have a pair where I know the angle and the side across. So I'm going to do sine of 80 over 13 equals the sine of whatever, pick, like I'll call this x, sine of 57 over x. So that would be this pair right here. And then again, I'm cross multiplying. So x times the sine of 80 equals 13 times the sine of 57. And then I would divide by the sine of 80. And then I would get that x is, what do I have? 11.07. Okay, so this is 11.07. And then if I want the other side, I would go through and I would do the same thing. I'm not going to go through and do that. It's the same thing, right? I just can't use a Pythagorean theorem to get the other side. I have to use the law of sines again. All right, let's see here. Now this one, we're going to see one that we don't necessarily just use the law of sines for. So for this one, really, when you look at these two, you might see, oh, 8 and 6, and this is 8 and 6, and this is 7. Well, that must be 7. The thing is, it doesn't necessarily always work out that way. All right. So actually it should. We'll see here. All right. Side. This is side angle side. Right. Side angle side. So what we're going to do is we're going to use the law of cosines. Now, if you were like, well, how am I going to know it's the law of cosines instead of the law of sines? Well, you only have one angle. And when you look, you don't know the side across. That's why you can't use the law of sines. So you might be, in my head, I always think first, can I use the law of sines? Oh, wait, no, I can't use the law of sines because I don't have an angle on the side across. But I always look for that first. So that means I have to use the law of cosine. So I'm going to write that one down. You might be thinking, okay, do I have to memorize this? We did put it on the resource page. But truly, by the time you get to the end of the chapter, you will have used it so many times that there's just no way you're going to forget it. Okay, the angle I know, it does happen to be labeled C, but if it was labeled B, it's the angle I know it goes in the place of C, no matter what. The side across it is little c. So I'll have c squared equals a squared plus b squared minus 2 times a times b times the cosine of 22 degrees. Now, to be honest, what I do, I don't feel it's not really cheating, but I just want to get it in as few steps as possible. Again, I'm not going to figure this out, figure out 6 squared, figure out 8 squared, figure out this, then subtract, then whatever. I'm going to put it all in my calculator in one stop. And if I want the c by itself, really what I need to put into my calculator is just the square root of that. So into my calculator, I'm going to type the square root of 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 22 degrees. So I'm going to type that whole thing in all at the same time. All right, let's clear this up. So square root of 6 squared plus 8 squared minus 2 times 6 times 8. Whoops, I think I do have 2 in there. Nope, 6 times 8 times the cosine of 22. So I get 3.87. Hang on a second. No, I don't. What's happening? This is 8 squared. Who's yelling at the TV? Or not the TV, the computer. I didn't square it. 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 22. So I get 3.32, right? 3, that's a 1, but that 5 bumps the 1 up to a 2. 3.32. All right. So C equals 3.32. Okay, remember for a second, I was like, oh, wait, these should be the same. But here's the thing. Over here, I don't know what this angle is. So I don't know how far spread out the 6 and the 8 are. So if you're looking at these saying, okay, that's 7, that has to be 7. But I don't know the angle on this one. I don't know how wide the 6 and the 8 are. So they're not necessarily the same. All right, so I know now C is 3.32. So now I want to find the missing angles. So to get the missing angles, okay, now look at what I have. I have a pair, right? I have an angle in the side across. So now to get my other angles, what I can do is use the law of sines. And it doesn't matter which one I get next. I'm just going to go ahead and get this. Why am I doing this? Stop doing that. I want to just highlight. Oh, I know why. Sorry. My brain's not working. Okay, so now I'm going to get angle A. I'm going to use law of sines. Now here I'm using the law of sines, but this is the first time I'm using law of sines to get an angle instead of a sine. So the solving will be just a little bit different. The start is the same though. So I'll have the sine of 22 over 3.32 equals the sine of A, let's do A first, over 6. All right, so I will start out by doing the same thing where I multiply the diagonals and set them equal to each other. And then I will divide off this 3.32. And then I will have the sine of A equals this. I'm just going to write it down for right now. Before I put it into my calculator, I don't want to put it into my calculator and round it because I have to do something else to get my answer. I want to know what A is. I don't want to know what the sine of A is. So to get the sine of A, I have to take the inverse sine, right? The inverse sine of the sine of A just leaves me with A. Well, then that means over here, I have to take the inverse sine of this whole thing. You could put this into your calculator all in one step, or you could put this into your calculator. You can put just this into your calculator and then take the inverse sine of it. Okay, either way, you want to not be rounding as you go. You want your most accurate answer possible. So let's see how we can do this in our calculator. Let's clear this all out. All right, so we're going to do, so here's if you didn't put it all in at once. If let's say to start, you were just like, all right, I'm going to put in 6, and then I'm going to do the sine of 22 over 3.3. Right, and I'm going to just get that answer. All right, I get this. Remember, the value of sines on your unit circle are between -1 and 1. So this makes sense, but that's not our answer because I actually want to know the angle. So I want the inverse sine of this. So I'm going to go to function here. Here's my inverse sine. I go back to main. If you click answer, it will pull your answer for you and you'll get 42.9 degrees. Okay, the alternative would have been to put it all in at once. So to start with the inverse sine of, and then go in and then type the 6 sine, I can do that on here, sine 22 over 3.3 all in one step. But you see, you still get 42.93 degrees. All right, so 42.93 degrees, 42.93 degrees. That's my A, 42.93 degrees. Let's come back up here. And so 42.93 degrees. Now to get angle B, I can just do 180 minus 22 minus 42.93 and get my answer. So let me just do this really quickly. 180 minus 42.93 minus 22 is 115.07. 115.07 degrees. Okay, so now I've solved the triangle. I figured everything out. And again, we could do, if we wanted to find the area here, right, it would be area. I'll just do another one of these just so you can see. AB cosine of C. Okay, again, I know this angle and I know these two sides. So I could do half times 8 times 6 times the cosine of 22. Is that the same as we did over here? I can't even remember anymore. Is that the same one we did? No, that was a 74. I'm losing it. All right, so 0.5 times 6 times 8 times the sine of, what do we say? 22 is 8.99 units squared. All right, now let's take a look at B. Let's flip this baby over. Make a little more room over here. Okay, now in this one, first of all, again, I would look, can I do law of sines? That one's easy to solve, but I have no angles, so I can't use law of sines, right? So this is side, side, side. If you remember that, then that would tell you, okay, that's law of cosines, or try law of sines, just plain wouldn't work, so you have to go law of cosines. Now, when you solve this, you should start with finding the biggest angle. Now, the reason for that has to do with this ambiguous case. If you remember with congruent triangles, there were side, 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 angle, and angle, angle, side. But there was not an SSA. Remember, you might remember this from geometry. You're like, oh, no, we wouldn't write it like that, right? We would write it the other way. The SSA did not always hold because it would give you sometimes one triangle, sometimes two triangles, sometimes no triangles. It was not a congruence theorem. It only worked in special cases. Because of that ambiguous, it's called the ambiguous case, with the law of cosines, when we're finding an angle, have to start with the biggest side. Okay, we're not going to go all into the law of side angle, so just kind of roll with me on that one. Okay, so we're always going to start with biggest angle, and that's across from the longest side. All right, so that means I need to start with finding angle B. So I'm going to use the law of cosines. Now, here's the thing with the law of cosines, though, right? I'm writing it out again. I am starting out with angle B, okay? So over here, it's the cosine of B. That means the side across from B has to come over here. And then these really do not matter. So I've got the 6 squared and the 8 squared again. All right, so now I have to solve for the cosine of B. And people try to do all sorts of wacky simplifying that just doesn't work. Sometimes people try to put all of this into their calculator at once and then tack a cosine of B at the end. But these are like, these can be combined because they don't have variables on them. This is all one term and this has a variable on it. It can't be combined with that. All right. Now, so I'm going to just get rid of this. You can't do that. Please don't do that. I'm saying no, don't do that. We'll say in class, don't do that. And somebody's going to do it. All right, so when I go to solve this, the way I do it to kind of make it so it's a little bit less on work on me writing wise, is I know I want this by itself. So I want to subtract off the 6 squared from both sides, and I want to subtract off the 8 squared. So I'll just like do that in my calculator. 8 squared minus 6 squared minus 8 squared. Those happen to be the same, so that actually makes this really fast. All right, so this is negative 36 equals, and then I can multiply these together, right? I can multiply these together and say negative 2 times 6 is negative 12, and negative 12 times 8 is negative 84. So I have negative 84 cosine B. So I'll kind of just do that in my calculator. All right, then I want the cosine of B by itself because I want to get B. So I'm going to divide by the negative 84. So the cosine of B equals, I really won't even divide this out. I'm just going to leave it. I know it's positive when I divide two negatives, so I'll drop those, but I'm just going to leave it because it's all going into my calculator anyway. All right, then I want to know B. I have the cosine of B is this, but I want to know what B is. So I'm going to have to take the inverse of both sides. So I have to do the inverse cosine of 36 over 84, and then that will give me angle B. All right, this one you have to write a little bit more out than on the other one. So inverse cosine of, what did I say, 36 divided by 84, which is 64.6 degrees. I just write 64.6 degrees. All right, so 64.6 degrees. I have something else written down from before. Man, oh man, I hope I didn't screw this up. All right. Oh man, does everybody see what I did wrong now? This should have been a 7. No, wait, it shouldn't have been. This should have been a 7. Oh my gosh, I can't even believe this. I'm so mad right now, and I'm so sorry. So sorry for confusing you, and I'm not editing this. I'm sorry, I'm also not doing that. All right, I'm really sorry, you guys. It's the worst. I know somebody the whole time has been like, somebody needs to tell her that you said the 8 goes here, and you said that these are your A and your B, and it didn't matter which, but I wrote an 8 again. Oh my goodness. All right, so back to the top, y'all. All right, let's fix those. I need to subtract 7 squared. It's negative 21. Then I multiply -2 times 6 times 7, which is -84. And before it wasn't -84, it was -86. I was looking at my answer key and pulling the 84 from that. And then divide the -84. I guess at least I caught it eventually, right? Ugh, hate it when I screw up like that. All right, so 21/84. And now we can take the inverse cosine of both sides. All right, inverse cosine of this and the inverse cosine of this. And let's see, now will I get the same answer that I got when I did it earlier, because now I have the right numbers. 75.52. 75.52. All right, so what did I just find out? B was 75.52. Now I need to find the two other angles. So I could do law of cosines again. I could, just pick a different angle and go through the same process. But to be honest, it's just faster now that I have a pair where I know the angle and the side across to find another angle. Okay, so I don't know. I'm just going to go with A. Sine of A over 6. All right, so then I have 8 times the sine of A equals 6 times the sine of 75. Let me slide this over. 75.52, and then over 8. And then I have the sine of A equals all of this. And to get angle A, I would do the inverse sine of both sides. So that, I would just put literally that whole thing in my calculator all at once. So let me do that. So I would have the inverse sine, and then I would go back here and then have a fraction. And we would have, what was it, 6 times the sine of 75.52, whoops, 52, divided by, what is it, 8? And then you get 46.49. So 46.49. So that's my angle A. And then to get this one, I would do 180 minus 75.52 minus 46.49. And then that would give me my last angle. So 180 minus 75.52 minus 46.49, and I get 57.99. So 57.99 degrees. All right, so I got one more because, of course, there's always going to be context questions when we are working with triangles, right? So here it says that you have two streets bounding your triangular lot to make an angle of 74 degrees. The lengths of the two sides of the lot on these streets are 126 feet and 110 feet. And you want to build a fence on a third side, but you only have 150 feet of fencing. Do you have enough fencing? So I want to know, I want to know what this side is. So I want to know the side across, but I don't have another angle, so I can't use law of sine. So I'm going to use law of cosines. So I'm going to have c squared equals, here are my a squared and my b squared. So 110 squared plus 126 squared minus 2 times 110 times 126 times the cosine of 74 degrees. And this is easy because I can just put, right, because I know every single number, I can just put this whole thing into my calculator all in one shot and get my answer. I don't have to go through the solving with the law of cosines. It's not that it's necessarily the hardest thing in the world. It's just just a hair tedious, right? So square root of, what do I have? 110 squared plus 126 squared minus 2 times 110 times 126, 26, and then times the cosine of 74. wait, 60, wait, that's not right, because I have 142, 120, oh. I typed in 12 squared instead of 126 squared, and that really throws things off. 142.60. Okay, so we have 142.60 feet. So do I have enough fencing? Yes, right? 142 is less than 150. So I have enough fencing. What are the measures of the other two angles? So now that I know that this is 142.60, then what could we do? We could set up a law of sines, get one angle, subtract from 180, and get the other angle. All right, so I could do sine of 74 over 142.60 equals the sine of whatever. Like, let's say this one, I'm trying to do, just be consistent here. Sine of A, we'll call it, over 110. Okay, so when you multiply, right, divide, take the inverse sine, you should get A is 47.9 degrees. So if this is 47.9 degrees and we subtract these two from 180, then we can get this one, which would be 58.1 degrees. And then it says the city has zoned the property so that any residents must have a square footage at least 1/3 the area of the lot itself. You plan to build a 2,300-foot square home. Will the city approve your plan? So that means then that I need to know the area of this. So if I want to find the area, I'm just going to use my given included angle, or my angle and the two included sides. So I'd say area equals 1/2 of, what was it, 126 times 110 times the sine of 74, which gives you 6,661.54 square feet. Okay, so that's the area, and it says it must have a square footage at least 1/3 the area of the lot itself. So here, if I do 1/3 of the area, that comes out to be 2,220.51 square feet. And so 2,300 square foot home is at least this, right? So then you could build your home that way. All right, that's it for law of sines and cosines.